Okay, exam 3 again, question 5, I believe. Evaluate the limit in two ways. Limit of x squared minus x minus 6 over x squared minus 9 as x approaches to 9. X approaches to 3. My bad. I'm tongue tied here. Should be 9. Okay. So there's two ways to evaluate the limit, one without L'Hopital's rule and the other with L'Hopital's rule. So the first way we'll do is with L'Hopital's rule. So we have the limit of x approaching to 3 for x squared minus x minus 6 over x squared minus 9. Here, we don't necessarily have to use L'Hopital's rule. We can factor out since they all have common factors of 3. So this would be x minus 3 and x plus 2 over let's see, x squared minus 9. I think that should be 9x. Let me double check. No, it's not. Okay. Well, let's figure this out. Actually, no. Yeah, we can still factor this. This can be x minus 3 and x plus 3, I believe. Let's check that. X minus 3 and x times 3 becomes x squared plus 3x. Yep, minus, yep, that works. Sorry for that. Just have to do a little bit of mental math. Well, when you factor this out, this would be x minus 3 times x plus 2, and this would be x minus 3 times x plus 3. You can double check by timesing them both. So x minus 3 times x plus 2. That would give you x squared plus 2x minus 3x minus 6. This would be x squared minus x minus 6. So that does correct out. And I just did this on the side not too long ago. So x minus 3 times x plus 3. This will give you x squared plus 3x minus 3x minus 9. This will give you x squared minus 9. So both do check out. Now that you're given this, your equation is x, no, not your equation, but yeah, your new equation. Yeah, your new equation would be x minus 3 times x plus 2 over x minus 3 times x plus 2. Oh my god, x minus 3 times x plus 3. And in this case, don't forget to carry your limit. And always carry your limit until it's applied. So now in this step, you can cancel out terms. So both of these are similar, so you can just cancel this out. So then your limit is limit of x approaching to 3 for x plus 2 over x plus 3. Now this is in the simplest form, you can plug in the limit. So this is 3 plus 2 over 3 plus 3, which is 5 over 6. That's your limit. So to give a recap of what I'm demonstrating, your equation is the limit of x squared minus x minus 6 over x squared minus 9 as x approaches to 3. And you can solve this by doing a factoring form. So the factoring form of x squared minus x minus 6 is x minus 3 times x plus 2 over x minus 3 times x plus 3. In this form, you cancel out both x minus 3 on the numerator and denominator, and so you're left with x plus 2 over x plus 3. Don't forget to always carry your limit until it's being applied. Once you have x plus 2 over x plus 3, you can then apply your limit, which is 3 plus 2 over 3 plus 3, which results in your final answer of 5 over 6. That's the first way without using L'Hopital's rule. Now we'll find out the second way using L'Hopital's rule. Because if you use direct substitution with just the given equation, you're going to have 0 over 0, which is the indeterminate form. So I should have done that first, but we'll do this now. So if you do it directly, direct substitution. Okay, so we have squared minus 9. This becomes 9 minus 3 minus 6 over 9 minus 9. 3 minus 9 is 6, 6 minus 6, 9 minus 9 is 0 over 0. That's an indeterminate form. That's why you can't use direct substitution. You can either use the factoring way or L'Hopital's rule. In L'Hopital's rule, you take derivative of both the numerator and the denominator. So this becomes L prime of h equal to the limit of x approaching to 3. And the derivative of x squared minus x minus 6 would be 2x minus 1 over square root of, or not square root, the derivative of x squared minus 9 would be 2x. So now it's in its simplest form again, so now you can apply the limit. Would be 2 times 3 minus 1 over 2 times 3. This becomes 6 minus 1 over 6, which is then again 5 over 6. So to give another recap, you can also find the limit using L'Hopital's rule, meaning that you take the derivative of both the numerator and denominator. So the derivative of x squared minus x minus 6 is just 2x minus 1, and the derivative of x squared minus x is 2x. In this case, don't forget again to always carry the limit until it's being applied, and the L'Hopital is simple. So after the limit is applied, you can just plug in the values and you get the same value as the factored form of 5 over 6. This is always tricky because, then again, when you're doing the factored form, it's important not to cancel out terms even though if they're not multiplying. So then, if you have this way, if you were to do it the factored form, you don't cancel out terms such as x squared, x minus 6. You don't cancel out terms right away like this, because that's not how it works. Both of these are not multiplying, so you can't cancel out those terms.